Assalamualaikum and good morning to all students. My name is Erny Afiza and I will be your lecturer as well as the coordinator for this course. As things are still uncertain due to the COVID-19 situation, I'm going to conduct all lectures online this semester until further notice. You may not have to know about this, but just to let you know that my room is in block 1, which is in front of the administration block at level 2, room number 7. So this is my email, erny@ump.edu.my. Please take note about this as we are going to use email a lot as medium of communication besides Kalam and WhatsApp. So again, welcome to BMM 2533 Fluid Mechanics 1. So first of all, let me brief a bit about the course. It is a 3 credit hour course which requires us 3 hours of lectures. At the end of this course, students are expected to fulfill all these 4 CLOs, course learning outcomes. First is to relate the basic principles and applications of various fluid conditions. CLO2 to analyze the problem in fluid statics and fluid dynamics. CLO3 analyze problem in pipe flows, flow measurement and dimensional analysis. And lastly, the course learning outcome number 4 is to justify the construction of an engineering problem accurately based on the fundamental of fluid mechanics. So as I mentioned before, we have 3 hours of lecture, a 2-hour class and 1-hour class per week. In 2-hour class, you are required to watch the given lecture video in Kalam. I will prepare the video and upload it into Kalam at the latest 1 day before class. Please do all the examples and exercise within the video. For the next 1-hour class, I will set up a Google Meet link. You are welcome to join the class even though it is not compulsory. I will be online for the whole 1 hour in case any one of you would like to ask anything regarding the lecture video, examples or exercises. The Google Meet link will be given to you through Kalam. For assessment, we will have 5 assessments which will give you the total of 100% of the course marks. Of course, the passing marks is more than 40%. Quiz will give you 5% of the total course marks. There will be no calculation included in the quiz as it will assess the understanding of the fundamental concept of fluid mechanics. Assignment will contribute 10% while report will give you 15% of the total marks. Report will be assessed based on the project given to you in the second half of the semester. Midterm test and final examination will give you 30% and 40% respectively. But please note that these assessment marks are subjected to change due to our current situation. So we have 5 chapters in total. Chapter 1 is about fluid statics. We will learn about pressure, gravity, density and height, stability and many more. So have you ever wondered why is it difficult to move underwater in comparison moving in the air? And do you know why dams are constructed thicker at their bottoms than at their tops as shown in this figure? Well, all of these situations are related to fluid statics, so hopefully we will get the answer in chapter 1. So in chapter 2, we will learn on the characteristic of flow in motion or dynamics flow. This chapter is the largest chapter in this course. You will stumble upon continuity equation, Bernoulli equation, momentum equation, and many more. Next is chapter 3, flow in pipes. You will learn about types of flow and Reynolds number, calculate losses, and eventually you are expected to know how to solve piping system using Bernoulli equation, which you have learned in previous chapter, chapter 2, considering all losses. Chapter 4 is a bit short. This chapter explains about devices that are used to measure flow rate and how does it works. And finally, in chapter 5, we will learn about dimensional analysis and similitude. This chapter is very important, especially for engineers as well as researchers. So these are the reference books that we will be using along this course. You may find it in UMP library. So finish with the course briefing, now it's time for review. As you may know, about 70% contents of this course involve calculation. So I would like you to refresh your mind with a few important things that I'm pretty sure that you have learned before, whether during diploma, polytechnic or high school. So first is unit conversion. Any physical quantities can be characterized by dimension. As shown in table 1 here, this is dimension column. So we can see here, length, mass, time, temperature, etc. are the examples of dimension. So how about units? Units are the magnitudes assigned to the dimension. Let's go back to table 1 here, and here is the column for unit. So unit for dimension length is meter, kilogram for mass, second for time, etc. In dimensions, we have primary dimension as well as secondary dimension. Primary dimension known as fundamental dimension such as mass, length, time and temperature, while secondary dimension is derived dimension such as velocity, energy, volume and many more. Let's take a look at the example here. So everyone knows that the unit for velocity is meter over second, which means the dimension is length over time. So we can consider that velocity as secondary dimension, which made of two primary dimension, length and also time. Next is dimensional homogeneity. We all know that you cannot add apples and oranges at the same time in engineering. All equations must be dimensionally homogeneous, which means every term in an equation must have the same dimensions. Let's say we are doing some calculations and we find ourselves in a position to add two quantities that have different dimensions or units. It is a clear indication that we have made an error at an earlier stages. So checking dimension is very important as it may help us to spot error. It may also can be used to check formulas and sometimes they can even be used to derive formula. Now let's take a look at this example. One of the most well-known equation in fluid mechanics 1 is Bernoulli equation. One standard form of Bernoulli equation for incompressible irrotational fluid is this equation. P plus 1 over 2 rho V squared plus rho Gz equals to constant, where P is pressure, rho is density, V is velocity, G is gravitational acceleration, and Z is the height. So can you verify that each additive term in the Bernoulli equation has the same dimension? And what are the dimension of the constant C? So please do this and revert to me in the next class if you have difficulties in solving it. So, moving on to the systems of unit. A number of unit systems have been developed over the years and two sets of units are still in common use today. It is the English system, which is also known as the United States Customary System, USCS, and the metric SI, which is also known as the International System. The SI is a simple logical system based on a decimal relationship between the various units, and it is being used for scientific and engineering work in the most of the industrialized nations, including England. The English system, however, has no apparent systematic numerical base, which makes it confusing and difficult to learn. For example, here, in the English system, force is often considered to be one of the primary dimensions, and it is assigned as a non-derived unit. This may cause confusion and error as it requires the use of a dimensional constant in many formulas. To avoid this inconvenience, we consider force to be a secondary dimension whose unit is derived from Newton's second law. In SI system, the force unit is the Newton and it is defined as the force required to accelerate a mass of 1 kg at a rate of 1 meter per second squared. In the English system, the force unit is the pound force and is defined as the force required to accelerate a mass of 32.174 pound mass at a rate of 1 feet over second squared. That is, a force of 1 Newton is roughly equivalent to the weight of a small apple, whereas a force of 1 pound force is roughly equivalent to the weight of 4 medium apples. So let's try this one. Try to convert meter to foot. So 1 meter equals to 1 meter times 100 centimeter over 1 meter. So this term equals to 1. 1 inch over 2.54 centimeter. So this term also equals to 1 times 1 foot over 12 inch. This term is also equals to 1. So we add these terms in order to cancel out the unit. As you can see here, you can cancel out meter, centimeter, and also inch. So this conversion, you may refer to the conversion factor, which is fixed. So finally, you can get the answer here, 1 meter equals to 3.281 feet. So now let's try to convert 1 liter to cubic meter. So 1 liter equals to 1 liter times 1 cubic centimeter over 1 liter times 1 meter over 100 centimeter times 1 meter over 100 centimeter times 1 meter over 100 centimeter. So this term here, these three terms are actually equal to 1. So 1 liter equals to 1 liter times 1 centimeter cubic over 1 liter times 1 meter cubic and 100 centimeter cubic. So you can cancel out the cubic centimeter and also liter. And finally, you will get your conversion 1 liter equals to 0.001 cubic meter. So here are the exercises for this introduction part. I have prepared for you a few questions and please do it at home. If you have any questions regarding this, please let me know in the next class. Thank you.